Okay, I'm making a second timing disc to be able to charge the caps and unload the caps in a two-stage type circuit where the caps fill up by themselves with no load, and then the caps by themselves hit the load. So I'm going to have Hall effects do that, tripping for this first stage. What I'm doing now, I'm going to use these solid state relays. Now I want to show you something that I just discovered. So here's a Hall effect, and I'll show you. Here's the way it is. Positive on the left, ground in the middle, the signal on the right. And that's, you need to have the Hall effect. See the shape of it up there? It's very small, but you have to have the shape of it like that. And now you have the positive on the left, the ground in the middle, the signal on the right, like I just showed you. And then I put a 22K resistor across there from signal to positive. Okay, so that's how you hook up a Hall effect. But now what I found out, and this is very interesting, it's like, let's say I have this little ceramic magnet I'm going to use to trigger it. I'm going to put it inside this timing. I already have this timing disc. This is for the motor coils. And it has 16 because there's 16 magnets in the rotor. So this is already working fine. My motor coil timing disc. I'm making another one now. And I'm going to put these in there. Little ceramic discs, magnets. Now here's what I want to show you. I just discovered this. See where the positive is? It's on top. Okay, so there's a pulse width of maybe a quarter, just over a quarter inch, comes up to it, and then it stops, and it doesn't trip anymore. Okay, so if it comes this way, comes up to it, stops, and doesn't go anymore. So the only time the Hall effect turns on the switch is between here and here, that distance. But here's what's interesting. If you take this Hall effect, flip it over like this, so the red is down, green is up. Now it doesn't do anything as it from the sweep from here to here, but now it trips from here to here. See that? It from here to here it trips when the green is up. Flip it over, and now it doesn't trip like that. It trips from here to here. So this is important to know when you set up your Hall effects and the timing. Now what I'm going to do is I'm going to have a, right up here, I'm going to have a neodymium magnet that has a long, wide magnetic strength to it. I'm going to use one of these little silver guys, just one, and that'll make a fairly wide pulse width to when the Hall effect turns on the MOSFETs or the relays or whatever. And that will stretch from about here to about over here. I tested it. About that long. A little bit longer than that. I'd say like this long. So I'd say it's 3/8 of an inch wide. Something like that. But now these little ceramic ones will only stretch from here to about here. So I want to have the neodymium magnet, trigger magnet, control when the switch or relay that fills the capacitor is on and when it turns off. So I'm using a normally closed switch so that the whole rotation, all 360 degrees, the switch is closed except for this much of it. And now it opens. Okay, and when it opens is when you want the discharge of the capacitor, because you don't want to have the capacitor connected to the generator coils when you unload the capacitor. I've been saying this 20 times now. So this is when the switch opens, so it's now disconnected. The rest of the time, the switch is closed and the generator coils are filling up the capacitor. Now, so I want the discharge switch that actually unloads to the load the capacitor while it's disconnected to be shorter in pulse width, because I want to make sure that it's not disconnected in the switch time and all that. So I have a wider pulse width for when it's disconnected and a more narrow pulse width when it discharges the cap to the load. Okay, so that's what I'm doing now. And I want to say the way I'm making a switch, like one of these relays or a MOSFET, if you use this Hall effect, AH3144E, it'll create a normally closed, switched open switch. And so I'm using a 4421 chip and a MOSFET, and for this will create that normally open, normally closed, switches open. Now this is what I usually use, these A1120LUA-T. This is what I normally use in my pulse motors, because it's normally open, and when the Hall effect, trips it, it switches closed and it turns on, pulses the motor. So this is going to be the Hall effect that will discharge the cap into the load. This will be the Hall effect that will allow the generator coils to fill the caps, but will disconnect it when it discharges. So that's what I'm up to now, and that's what I'm going to be doing. Hopefully I'll have it working tomorrow. Okay, thanks a lot. Okay, thanks for watching.